Kinetic molecular theory is a model that helps us to understand the behavior of gases. And models and theories are really nice because they help us predict what's going to happen and help us explain things. And I always like to know why stuff is happening. So kinetic molecular theory is a fairly simple theory, and it works for a lot of situations, but it doesn't work under every situation. It breaks down under certain conditions. So, because one of the nice things about an intro chem class is you can just ignore the complicated stuff, right? So we're going to ignore places where kinetic molecular theory doesn't work, and we're just going to focus on the majority, which is where it does work. So here's kinetic molecular theory. 4 principles. Gases are collections of particles, and those particles are in constant motion. So they've got these little vapor trails or whatever here, suggesting that these little balls, these molecules or atoms, are moving. There are no attractions or repulsions between the particles. The collisions are elastic, which means that they're like billiard ball collisions, except they're perfect. So one ball comes in and hits another one, it transfers its energy to the second one. These atoms are on the very small scale, and so they don't experience friction or anything. And so they'll just keep moving at a constant rate of speed until they run into something. When you throw a baseball or fire a bullet, why does it slow down and eventually fall? Gravity's part of it. But there's resistance in the air. These gas molecules are the air. They don't have any resistance. They're moving through nothing. So they don't experience that wind resistance. So they run into each other, they don't stick to each other, they just bounce off. There's a lot of space between the particles compared to the size of the particles themselves. Lots and lots of space. And the speed of the particles increases with increasing temperature. That should be somewhat familiar. I've talked about barefoot people on hot sand, right? And that's generally true for all matter. If you increase the temperature, temperature is a measure of the average kinetic energy, and so the motion of the particles is going to increase. But unlike solids and liquids, especially solids where they're just vibrating, these guys are actually traveling, they're moving. And so you increase the temperature and the gases move faster. Any questions? Have you guys heard of the game Pong? I was actually alive when Pong came out. It was really cool. It's so pitiful. I mean, it's not even a good cell phone game anymore. I'll just draw you a little Pong screen down here. So there was this little blip, it wasn't even round, and you had a paddle down here. And you'd move this back and forth, and this little blip on the screen would it'd be moving in one direction, and it would go, and it would hit, and it would bounce off, and it'd come back, and then you had to move your paddle and catch it to keep it going. And it would just never speed up, never slow down, it just kept going, and you just kept catching it. And sometimes you could get it set up so that it would go in the same square and it could just go there forever. That's the way gas molecules are. They just travel in a straight line till they run into something. Then they bounce off and they keep going. If you heat them up, they'll move faster. If you cool them down, they'll move slower. But if you keep them at the same temperature, they just keep moving. The kinetic molecular theory is consistent with our observations about gases and helps us to understand those observations. We have observed that gases are compressible. Liquids are not compressible. If you put a liquid inside of a piston and you push down on it, you can't compress it. Because these liquid molecules are already touchingly close, there's no empty space that you can squeeze out. Kinetic molecular theory says there's a lot of empty space between the gas particles. So if I press down on this piston, I can squish them closer together, because I'm just squeezing out some of the empty space. You can't do that with liquids and solids. but gases you can, and this explains why. We also learned that gases assume the shape of their container, which is also different than liquids and solids. So how does this happen? Well, kinetic molecular theory says the molecules in a gas are not attracted to each other. They do not interact with each other. If they bump into each other, they just bounce off and keep going. Why does water stay in the bottom of a cup? The water molecules are attracted to each other. They're polar molecules, and the dipoles attract each other like little magnets. And so the water molecules at room temperature stick to each other, and then gravity holds them down at the bottom of the cup. These guys don't do that. They're not attracted to each other. They just bounce off and keep going. And so they will spread out to fill the whole container. The particles are in constant straight line motion. It's going bang, and they hit something and they bounce off. Gases have low densities compared to solids and liquids. And this is because there's so much empty space between the particles. Density is the mass divided by the volume. If the volume is much larger because of all that empty space, then the density is going to be lower. If you took 1 can of orange soda, which is a liquid, and turned all of that liquid into a gas, it would occupy the volume of 1,700 cans of soda. That's a little bit of a difference in volume, right? As a gas, those molecules that were in this liquid have the same mass. Their mass is the same, but the volume is much, much larger. So gases have very low densities. Any question?